Hiya and welcome back to my channel. Today, by the end of this video, you will have learnt about direct and indirect proportion. We'll also have gone through some exam questions.
Direct and inverse proportion is a maths topic that can be applied to the real world, from cooking recipes to budgeting for when you have friends round for a takeaway. It's one of those topics that's actually really useful. You're also probably here because you want to do well in your exam, so don't worry, we'll be going through some exam questions as well. So, what does proportion mean? Well, proportion is the relationship between how things are all related. For example, if the number of people following you on social media increases, does the number of likes you get go up or does it go down? Usually, if your number of followers goes up, you'd expect your number of likes to go up as well, but obviously, in the real world, there are other factors in play here. Maybe your followers are not that engaged or you've bought followers, and then you wouldn't always expect the number of likes to go up. But hopefully you get the idea. So followers would go up, then number of likes would also generally go up at a similar rate. A potential example of direct proportion could be if you spend more time revising effectively for your exams, would your exam results go up? Well, you would hope so. However, they wouldn't necessarily go up proportionally to the time spent because you can never get over 100% on an exam. Let's look at what proportional means algebraically. So, on the left-hand side, this means y is proportional to x, and on the right-hand side, this means y is inversely proportional to x. On the left-hand side, you would also call this direct proportion, and as I mentioned on the right-hand side, this is inverse proportion. And we can rewrite these by replacing this alpha sign here with an equal sign and a constant k. We don't have to call this constant k, it can be any other letter instead, but that's just the convention. I should also have actually used a different letter for the right-hand equation or the left-hand equation just to avoid confusion, so sorry about that. Looking at what direct and inverse proportion look like graphically, on the left we've got direct proportion and on the right we've got inverse proportion. So for direct proportion, as your independent variable increases, the dependent variable, which is dependent on how the other one behaves, will also increase. For inverse proportion, if we think back to the equation, y is equal to some constant divided by x. As x increases, y will get very small but never be zero, and as x decreases, y will get very large and tend towards infinity, and that's why it never crosses the axis. Now let's go through some real GCSE exam questions together so you can get a feel of what's expected from you while sitting the exam. So here we're told that t is directly proportional to the cube of r. We're also told that t is 21.76 when r is equal to 4, and now we need to find a formula for t in terms of r. So we know that t is directly proportional to r cubed, so t is equal to some constant k multiplied by r cubed. Next, what we'll do is we'll sub in the values we've been given, so 21.76 is equal to k multiplied by 4 cubed. If we rearrange this, we know k is equal to 21.76 over 64, which is equal to 0.34. So all we need to do to find a formula for t in terms of r is sub this value of k back into our original equation, and there we have it. Okay, so next, the mass of an ornament is m grams. The height of an ornament is h centimetres. M is directly proportional to the cube of h. M is 1600 when h is 8. Work out an equation connecting m and h. So, we're told that m is directly proportional to the cube of h. So, we know that m is equal to some constant k multiplied by h cubed. Subbing in 1600 for m and h as 8, we can rearrange to get that k is equal to 3.125. Subbing this back into our original equation for m in terms of h, we get m is equal to 3.125 h cubed. So this is pretty similar to how we did the first question as well. So we'll look at inverse proportion now. So y is inversely proportional to the square root of x. Y is 40 when x is 9. Find a formula linking x and y. So we're told that y is inversely proportional to the square root of x, so y is equal to some constant, all divided by the square root of x. Next, we'll sub in the value for y, which is 40, and x, which is 9, to get a value for k. So k is equal to 120, and then, same as we did for the questions before, we'll sub in this value of k, the constant, back into our original equation to get y is equal to 120 divided by the square root of x, not k like I wrote, sorry. So here's another example of an inverse proportion question. Y is inversely proportional to x cubed, and y is 44 when x is a. So now we need to show that y is 5.5 when x is equal to 2a. So, creating our equation as normal, y is equal to k all divided by x cubed. Then we'll rearrange this to get a value for k, which is 44a cubed. Subbing this back into our original equation, we get y is equal to 44a cubed over x cubed. Now, to answer the question, we need to show that y is equal to 5.5 when x is equal to 2a. So if we sub y equals 5.5 in, and we get a value of x which is equal to 2a, then we've answered the question. Subbing in 5.5 and rearranging to work out x cubed, we get x cubed is equal to 8a cubed. So cube rooting each side, we get x is equal to 2a. Therefore, we've answered the question. This next exam question is a bit more tricky than the rest. So, y is inversely proportional to d squared. When d is 10, y is 4. And then we're also told d is directly proportional to x squared. And when x is 2, d is 24. Find a formula for y in terms of x and give your answer in the simplest form. So here, we've got one equation for inverse proportion, one equation for direct proportion. And then we've got to work out y in terms of x. Breaking it down, we'll start with y is inversely proportional to d squared. So y is equal to some constant k divided by d squared. When d is 10, y is 4, so we can rearrange this to get that k is equal to 400. Subbing this back into our original equation, we know that y is equal to 400 all divided by d squared. So next, d is directly proportional to x squared. So d is equal to some other constant, let's call it m, multiplied by x cubed. Here in my workings, I've carried on with x cubed instead of x squared, so try the question again yourself at home. Subbing in x is 2 and d is 24, we can work out m, and we work out that m is equal to 24 over 8, which is just 3. Subbing this back into our original equation, we know that d is equal to 3x cubed. What we then do is sub this back into our original equation for y, and then we'll eliminate d and have y in terms of x. So eventually we work out that y is equal to 400 all divided by 9x to the power of 6. So not so tricky after all. With a question like this, the best thing to do is just write down what you know and break it down, and then you'll get there in the end. So another type of question that exam boards like to throw at you for direct and inverse proportion is these graph questions. You'll see a few of these come up. So we're asked to identify the graph, which is y is directly proportional to x. So we know y is equal to kx, therefore it's the first graph. It's just a straight line graph. The second is y is inversely proportional to x. So we know as x gets really big, y gets really small. And as x gets really small, y gets really big, and therefore that one is graph C. What you can do is just take the constant in each example to be 1, and then just sub in a few values for x and y and plot these on a graph, and this should then make a bit more sense if you're a bit stuck on this. Believe it or not, this next question is exactly the same pretty much from a different exam board in the same year for GCSE, so do just learn this one and make sure you understand it because it does come up frequently. So y is directly proportional to x squared. Again, we now know this is graph A. Part B is y is inversely proportional to x. We already know from the last question that this is graph C. The third part, which we haven't actually looked at, which is question 10, is sketch a graph which shows that y is directly proportional to x squared. And if you think about the parabola, y is equal to x squared, then you know what that looks like. We're plotting it here for only positive values of x and y, therefore it'll just be half a parabola. If you find any of this confusing, just drop me a note in the comments and I'll try to get back to you. So here again, super similar. We already know y is proportional to x is going to be the second graph, y is proportional to x squared. We've also just worked this one out. There's going to be graph D. The last one is y is inversely proportional, so we know that one's C. So the only one remaining is going to be A. So again, one of those questions, it just comes up. So just learn and make sure you understand it. As I'm sure you've noticed, there's a bit of a trend with all the exam questions on this topic. So just make sure you've done a few, go through this a few times, and if you need any help, again, as I just said, drop me a note in the comments or follow me on Instagram and I'll see what I can do.
Thanks for watching. I hope this video has been useful. If you found it helpful, please don't forget to like, comment and subscribe to my channel for more videos. Thank you.